In order to destroy the moon, which we decided to do many, many years ago, we figured we needed a launcher in order to accomplish this. This launcher then used physics concepts that we use every day. These concepts included conservation of energy, kinematics, and projectile motion. Using the spring potential energy and the kinetic energy of the tennis ball after launch, or whatever projectile we will use to destroy the moon, because screw the moon, we set them equal to each other and then solve for the initial velocity of the projectile. After doing this, which the equation was V0 equals x square root k over m. After that, we plugged it into the projectile motion equation, delta x equals t V0, whatever. Then after this, delta x equals xt square root of k over m.
In our efforts to destroy the moon, we figured we might want to test out our contraption, so we performed a number of trials to test how far our tennis ball would go. In trial 1, we pulled back on the launcher with 100 newtons of force at a launch angle of 25 degrees. The tennis ball launcher was pulled back about 1 meter, and the tennis ball went about 34 yards. In our second trial, we pulled back with a force of 80 newtons, again at a launch angle of 25 degrees. This time, the tennis ball launcher was stretched only 0.87 meters, and the distance was the tennis ball went about 22 yards. On our third trial, we pulled back with about 150 newtons of force, this time with an 18-degree launch angle. The tennis ball launcher was pulled back about 1.5 meters, and it went about 40 yards. In trial 4, we pulled back with 200 newtons, this time with a launch angle of 14 degrees. The tennis ball launcher was stretched back 2 meters, and the tennis ball went about 44 yards.
We first originally thought that time was an important factor in our experiment during the trials. We were wrong. We actually forgot to mention time. Actually, we didn't have the tools to calculate the time. Okay, fine, we forgot about time in general and everything about it. But in the end, we actually saw that time wasn't that important because we somehow got into our equation that, we didn't have to mention time or anything. But our evil headmaster, Dr. Tumnus, he originally told us that we needed to do a final launch to test our little spring contraption thing that, it's not that technical, but he told us that we needed to hit a specific target, a little green target, and we almost hit it. We were just 0.9 meters off, but it's pretty close. So I'm pretty confident that we'll be able to hit the moon with it very soon. Very soon, yes.
The procedure for this launch was taking the hurdle, setting it at its highest setting possible, placing the launcher at the 2 notches available in its highest setting, and then having 2 people stand on the edges of the hurdle, very close to the starting height where it begins to rise off the ground, placing their feet there, keeping it steady, and then pulling back on the launcher to make sure the tension in the launcher is equivalent throughout the entire thing. After this, someone then places a tennis ball inside the launcher, pulls it back at various distances and forces, and releases it after measuring the angle and the displacement from the starting position of the launcher, and then recording everything after that, including the distance traveled, I got nothing now.
After we got close to the distance that Dr. Tumnus wanted us to launch, which was, the target that he, had out for us. And by the way, we almost hit him. It was kind of funny. But we tried launching it at the moon, which we failed miserably. It was awful. Time was an important matter for that launch, not the moon launch, not the distance that Dr. Tumnus put up for us, because that was a great launch. But yeah, I think we forgot a bunch of other physics concepts that we should have taken into consideration. Also, how far away the moon is, which is pretty far. But yeah, hopefully we don't get punished by Dr. Tumnus. If you're watching this, Dr. Tumnus, don't kill me, please. I love my family. Thank you.
1, 2, 3. We are soup.